Good afternoon and welcome to the J2X engine test post-test press conference. My name is Daniel Kanigan, NASA Public Affairs Officer, and with me to my left are Daniel Dunbar, NASA Deputy Associate Administrator for Exploration Systems Development, Jody Singer, NASA Space Launch Systems Deputy Program Manager, Patrick Sherman, NASA Stennis Space Center Director, and Mike Keinert, NASA Space Launch Systems Liquid Engines Element Manager. We'll begin with brief statements from each of our participants and then open it up to questions. Dan?
Thank you, Daniel. Good afternoon, everyone, and thank you for coming. What a great day, a great test. Another mark in our progress in getting the exploration systems developed, along with the testing we have going on with Orion, both in Denver and at Langley, the engine testing here, our booster testing that we did recently out at Utah. All good hardware progress, and I think the team today did a great job demonstrating good hard work, and we appreciate everything they've done, and we're going to make this happen.
Okay. Hi. I'd just also like to say the same thing that Dan has said. It's a wonderful day. It's a great achievement. Mike Keinert and his team, J2X with our contractor, Pratt & Whitney Rocketdyne, as well as the partnerships that we have with Stennis have made today successful. It's the people that have worked hard to make this happen, and it really is a great feeling to see what we can do and to go forward with this type of technology for the future.
Thanks, Jody. I'm going to echo those words. It is about the team here from Stennis Space Center. We're proud of the role that we play in support of this program. Very important to the nation. And what you heard today was the sound of the front end of the critical path of the future. And that sounds pretty good to me.
Yep. I'd like to add to what they had said. I think back on this day, it's a wonderful day. And I think back to the design, to the analysis we've done, to the manufacturing. The J2X team, both the Marshall and the Stennis guys, and along with our Pratt & Whitney Rocketdyne contractor partner, and to see the seeds that we planted a few years ago come together like this, and to hit this important milestone for our testing, and then to see it go from here on and finishing the maturity of this engine and getting back into flight.
All right, thanks, Mike. We'll open it up for questions now. If you'd like to ask a question, please raise your hand. Mike will be passed to you. Also, please remember to state your name and affiliation.
Good afternoon, Vanessa Bolano with WGNO News out of New Orleans. I'm wondering, I've been hearing we've reached the 500-second goal here. When are we going to see this engine actually take flight, take us out of Earth into space?
Do you want to take that one?
No, but you.
Okay. As far as the J2X, it's going to be a critical part of us going beyond low Earth orbit. Right now, the first flight is after 2021. Right now, we're doing all the design and study and testing and taking the technology out of it, applying it to our engines that we're going to fly on the core, as well as using production technology, different things that we come up with to make sure that we can deliver and payload to space beyond low Earth orbit.
Next question.
Hi, Lee Root with the Huntsville Times. I guess this is for Mike. It sounded good where we were. How did it sound where you were, and were you able to tell anything immediately afterward about the engine and how it looks?
Sure. Yeah, it did sound great, didn't it? And so we went down and took a look at the data. We have a lot of guys on console, and while we've got a lot of data to pour through, and for 500 seconds of good data, we got a quick look of it, and the engine performed exactly as we expected it to. We're going to pour through to make sure that all the if we find any issues, we'll take care of those. But first look is it ran great.
Next question.
Vanessa Bolano again with WGNO News. We hear a lot about the future of exploration, and a lot of people not sure what it means, especially after we've seen funding cuts. What is the future of space exploration? What can we expect for the next 20, 30 years?
Well, I think the future, you see one of the early steps of it here today, as Jody talked about getting this engine ready for our eventual heavy lift rocket to take crew and cargo beyond low Earth orbit. Eventually, we're going to Mars. We have near-Earth asteroids, the moon, other destinations between here and Mars that we're going to go visit. The future is bright for exploration, recognizing we do live in a constrained budget environment at this point, and we understand that, and we've set up the program to live within those, within that funding environment. But the future for exploration is bright because we're building the systems, and you see the evidence today of part of the team and an important part of the team, along with everyone else working across the country to go get the crew capsules, the launch vehicles, the transportation system in place so that we can go beyond low Earth orbit. And this is an early step, but it's evidence that we're making progress, and we will continue to work towards exploration.
Hi, Mary Perez, Sun Herald. Where does Stennis Space Center fit in the exploration?
Well, I'm proud to say that we fit, right now is, and the future of NASA is happening today. You heard the J2X test successfully today. We are also supporting the COTS program that's going to be resupplying the space station with the AJ-26 engine in another test stand. And we also are awaiting a delivery of the thrust chamber assembly from Blue Origin, which will be supporting the commercial crew program as well. So I expect big things for Stennis. Stennis has had a traditional role in rocket test and a very strong relationship and partnership with the Marshall Space Flight Center, and we look forward to that happening over the next 30 or 40 years.
Hi, Lee Roop again. I guess for Mr. Dunbar, we were told today that you're going to test, I think, 5 developmental engines and then 2 engines to certify before you get to a flight engine. If that's right, why so many engines? I mean, why do you have to test so many engines? Couldn't you maybe test 3?
Well, I'll take a first cut at that, and then I'll turn it over to Mike. The reason we test different engines and the number of engines we test is based upon the need to demonstrate the engine performance, also repeatability, and to get a good understanding of how the hardware will work in the various environments in which it will have to operate, and to demonstrate all of our processes and procedures that you need to develop and build that engine. So Mike and his team have done a great job of making sure we understand what we need to do, what we need to test, and then laying out an efficient test program to go meet those needs, meet those test objectives so that we can demonstrate good hardware. We continue to work that, and the team has done great, and we just continue to look for those things. We do the testing so that we can learn and understand how things operate, and right now that's our plan, and Mike and his team have done a great job. And I'll let Mike go into any further details about how we choose the numbers.
Yeah, Dan hit it pretty good. We want to make sure that we have a good design. We also want to make sure that we understand how to make a good repeatable design. And also we want to drive out any issues that we have while on the ground, so we make sure not to have them in the air. And so we want to test several times. You say that fly so many engines. We're actually doing it with fewer engines than anyone ever has for this class of engine, and we understand the need to try to get that. As modern analysis techniques improve and things like that, we will be able to continue to take steps towards less and less engines for demonstration. But we've taken a big step with J2X, and we would continue to do that with future engines. And we just need to get to know this thing and make sure it's working just like we designed it. One of my mentors says, the hardware knows the truth. We just need to get to know the hardware.
Twofold question. Wondering how many people from start to finish, including all the testing, does it actually work on an engine like this? And also, how much does something like this cost?
Back to Mike.
All right. Yeah. For test day, there's about 30 to 35 folks that are operating both the facility and watching over the engine. Our team of people that do the design analysis and manufacture back in Pratt & Whitney Rocketdyne is around 400. We have some folks that help at the Marshall Space Flight Center and down here at Stennis Space Center, and we total about 150. A test, we really talk about those in terms of test series, but if you were to try to get down to what does a single test cost, it's around $350,000. But when we apply that across, several months and those kinds of things, it averages out. But we get about 28 tests out of each engine, and then we move to the next engine, and that's kind of the life of the engine as we begin to understand it to its maturity.
Other questions? If there are no other questions, then that'll conclude today's proceedings. For more information on the J2X engine on the NASA Space Launch System, please visit www.nasa.gov/SLS. Thank you.